Hey there, I'm sitting with Puff, and he is a Firebase engineer at Google who will hopefully be able to help me with a security issue that I'm having with my app.
Let's try.
Yes, so let me explain a little bit about what's going on. So, I basically have two issues that are very interconnected, and they all boil down to the fact that I'm using the user's email as basically in place of their UID. So the first thing that we do in the app is when they sign up with an email and password, I have this really nice flow where I basically use Firebase's reset password functionality to make sure that the user actually owns the email that they say that they do. But I realized when I was writing the security rules that if somebody isn't using my client app and they're instead either just writing their own JavaScript or using a badly made app of some other variety, that they could get around this flow that this really nice flow that I've set up. So I realized there's no way to really trust that the user owns the email that they said they do. And then on top of that, I've got the email basically everywhere in the security rules, and I just don't know, how secure that is, how to make that secure in the security rules. So you are a security rules guru. Can you help me?
Ooh, that sounds like a good challenge. Okay, let's take it one step at a time.
Okay.
So the first thing is indeed your email verification flow, right?
Yeah.
Because you are using Firebase's reset password flow, which is great, and it's a great use of that flow in your Android app. But the problem that you run into now is that since the code runs on the user's phone in their Android app, you have to trust the user to write back their email address into the database. And that is where you now have a security problem. Is that correct?
Yes. I mean, if they're using the app, things should be fine. But if they're not using the app, if they just write their own JavaScript.
Exactly. So, and this is what we see very, very often with developers that are using Firebase. You want to trust that it's your code modifying the database. But there's really, since Firebase is a cloud-based database, there is no way to be guaranteed that it's your code that's writing. The only thing you know is which user is writing to that database. And that's what you see with the Android app, right? You can verify that it's the user that signed into the Android app that is writing the email address. And you can do the same no matter if they wrote their own Android app or even if they were using a JavaScript client. You can verify that it's that user that's writing the email address. What you can even validate is that what they're writing is an email address. You can validate that there's an ad in there, right? You can validate validate the value. But you cannot verify that it's actually the correct email address. That's where you're, essentially losing the security battle.
Yeah, and we're doing that type of stuff. We're validating that it looks like an email address. So basically what I'm hearing is that it is either very hard or impossible to do this kind of stuff on the client side or with the security rules. Is that true?
Yeah, the problem indeed is that you must verify the email address in an environment that you trust, and you should not trust the user's Android phone.
Okay.
So the only option there is actually to take the same flow that you have on the phone and move it to a trusted environment. And typically then you think of a server, right, where you essentially take the same flow and you run through it. So the user, right, you send them an email with a password reset type thing in there, essentially a shared secret. And they can only validate that they own that email address by typing that secret code into some interface that you define. The flow is exactly what you do today. The difference is that it now runs on an environment that you can trust. And that means that it runs under somebody else's identity. So that's also how you secure this flow in the security rules, is that you verify that it's written from a trusted identity and not from just the user that is running the app on his Android phone.
So I really like what you're saying, that basically the flow itself doesn't have to change. We can probably use at least similar code to what we already have. The thing that makes me nervous is when you say a server. So how, sort of heavyweight are we talking about? What would I need to do to set up something like this?
Yeah, and this is a very common a question we get on Firebase as soon as we mention running server code. Yeah. This is not your typical infrastructure server. This is essentially a trusted device that runs the same type of code that you would run on the Android phone or on a web page, but it now runs in a trusted environment. So you could run this, I always say that a lot of my maintenance scripts run in JS Fiddles. I'm not saying you should do that, but since I don't myself run, these are for my own research type databases, since these are not really production, I just run the maintenance whenever I feel like it. But it is trusted because only I have access to these scripts, so only I can run them. Just like that, you could run them on a small Google Compute Engine instance, for example, or on an EC2 instance. And it can really be like the smallest one that you can get there, because you don't need to do a lot of work. Or if you really want to, you could even run it on your own Android phone. You could have the exact same code, it runs on your phone, and since it doesn't run on my phone, you know that you can trust it.
Interesting. I guess I just have to keep my Android phone on all the time.
Yeah. No, that's the only thing you need to do.
So, I mean, that doesn't sound like the scary type of server, I suppose, but you know, we're kind of already in the thick of things. Are there any options for working without a server that could still get us, you know, where we want to go?
Ooh. Yeah, this is going to get more challenging. So this is where you need definitely to add some steps into the current flow.
Okay.
So right now, the problem that you have seems to be that you trust that if two accounts have the same email address written into their profile data, that it's the same user, and that those are the accounts that you want to merge. And this is something that you should not do, because right as we covered before, you cannot trust that the email address they write is an email address that they own. So you really must find another way to get these people to agree to merge these accounts. So a very common approach would be to actually put a mutual agreement type of flow in there. So instead of merging the accounts like you do now, you actually require that the user proposes to merge an account, and that then the account that they want to merge into has to accept that proposed merge. And since you already have a friends list, you sort of have the mechanism in place there to identify which accounts you want to merge. So you don't even have to rely on the email address there. You can also have them select the accounts that they want to merge into.
Okay. So a lot of extra code on the client side is what I'm hearing.
Yes, definitely. Yeah.
So besides adding sort of bulk to the client side app, would this add any kind of bulk to the security rules themselves, or what would that look like?
Oh yeah, definitely. No, you need to write some security rules for like the place where these users meet up and agree to merge their accounts. And I've written some examples for that to essentially highlight how that would work.
Oh, that's super helpful. I guess we'll take a look at those later. So.